Assalamu alaikum and welcome to our channel. I am Dr. Hamad Ismail. In the series of Gromacs tutorial, today we have the third lecture in which we are going to demonstrate about the analysis. After the ligand protein complex in the MD simulation, analysis is the key step. We will cover these analysis steps in multiple tutorials. Today we will talk about the main key tutorials which are available on the Gromacs website. After that, we will cover the RMSD value calculation, RMS value calculation, surface area calculation, and so on. So stay in tune our channel. Today we are going to talk about recentering and rewrapping the coordinates, protein-ligand interactions, analysis of ligand diagrams via dynamics, protein-ligand interaction energies. So let's start. With the quick recap, we make a folder in our previous tutorials. We make a folder on the desktop with the name GMX. In this folder, all our simulation files are present. Then we created an environment in the Ubuntu WSL system. First of all, we will, as we are going to take a fresh restart, we are going to activate it. First of all, I will source my folder by adding this command. This command is cd mnt, which means mount at the C user desktop GMX. If you can look at this, you can copy and paste your command. You can modify your command using this information and press enter. Now we are in the folder in which we are going to work. Second is you have to source your Gromacs, which we created in our previous lecture. Copy, paste and enter. And the third, we need to activate these sources, this environment. We created the environment with the name Gromacs _ env, which means environment. Copy and paste. So our environment is activated. I will paste all these commands in the description section for your ease. In the Gromacs tutorial, today we are on the last step, which is known as the analysis. It is about the recentering and wrapping. For our ease, we change the name to the UNK. We will demonstrate this tutorial according to our modified script. First of all, we are going to centralize our trajectory. I have completed the run for the 10 nanoseconds. That's why I typed it the 10. If you have completed it 1 nanosecond, you can change it into 1. If you have completed into 100 nanoseconds, you have changed it into 100. As in the previous tutorial, we used 1 nanosecond, so I'm going to change this command as a 1, so your previous and current command are matched. Now copy this command and go to your Ubuntu, paste it and press enter. It's asking for your groups. The first group is it's asking for centering. For centering, we are going to give it to the protein. For protein, the number is 1. Type 1, press enter. At the second level, it is asking for the output. For output, we are going to give it to the system. For system, the number is 0. So press 0 and press enter. And it's completed. Then our second command is recenter trajectory. Now we are going to recenter the trajectory. For this, copy this command and paste it in your Ubuntu. It is asking for the out group. Again, here choose the system as out group. For this, choose 0, type 0 and press enter. Completed. The third step is rotational and translational fitting. For this, copy this command, go to Linux, paste it and press enter. This one is asking select group for least square fittings. For this, we are going to choose the backbone. The backbone is at number 4. Type 4 and press enter. Now it's asking for the output. For output, we are going to choose the system, press type 0 and press enter. It's completed. After running this command, we have completed the C centering and wrapping coordinate. These functions are completed. This is done, and this one is also done. Now we are moving toward the next step, which is analysis of protein interaction and ligand dynamics. For ligand interaction and ligand dynamics, first run this command. It will give you the idea of your ions. It is telling us that these items are with the name OE1 and these items are the name of OAB. So once we know that, the second step is we want to know the distance, and we have given our name, the ligand name is U and K, and OB and AB are our molecule, plus we have added the information that there is an interaction between residue number 102. It is basically the interaction we already know from the literature, that JZ4 or some other molecule bind to the protein or lysozyme at this particular position. If you know some other position, you can change the number as per your requirement. For this case, we are going to copy it and paste into Ubuntu and press enter. And it's completed. The information we got from here, that the average distance is 0.39 nanometer while the standard deviation of distance is 0.11 nanometer. At next step, we want to make a new file which index.ndx, which determines the angle between these molecules like residue number 102 and OE1, which we know the energy, but we want to know the angle side. For this, we make a new ndx file, index file. Copy this command and paste into your Ubuntu Linux. It gives you an options. Type here the 13. 13 is our ligand with node U and K, and a OAB, which was previously present with the ligand binding, and H12. Press enter. Now type 1. 1 is for the protein. You can see here the protein and residue number 102 at OE1. What this represents? This represents at U and K 13 position at bonding OAB. It is binded with at protein number 1 at 102 at position OE1. So OE1 on OAB is basically the binding site between the 102 number residue. When done, press enter. So number 1 position present protein and number 13 position present U and K, which is your ligand. Now type 21 and 22. Why we are typing 21 and 22? These are basically the next position after 19, which present your these molecules are going to add the entries, which I show you later. If it doesn't work for you, you can add 20, 21. If this also doesn't work, you can add 22, 23, because we don't know, maybe some hidden molecules are present over here. So let's try 21 and 22. So it's giving an error that copied index 21 is this one and group 22 doesn't exist. So we try 20 and 21 and press enter. So it's now clear, it's completed. It says that copied index with this name group 20 and with this name protein underscore this is 21. We are done here. Press Q, which is quit, and press enter. The job is completed. I have added this command over here for your ease. Now the next step is to find out the angle. As we have used 1 nanosecond, our all files are with the 1 nanosecond, we are going to use this one. Copy this command and then go to Linux and paste it. From the here you have to choose the last option. In my case, the last option is 23, while 21 and 22 are some protein based which we added double, so it doesn't matter, but we need to know the last option 23. Type 23 and press enter. So the output is this one. It is giving you the angle which is 36.839, which means the angle between the ligand and protein at which they are bind with 102 residue, their angle is 36.831. The angle we got is 36.83. The Gromacs calculated it as per the acceptor donor hydrogen, which is not a correct sequence. The correct logical sequence is donor, hydrogen and acceptor. First they need to align the donor, then the hydrogen, then the acceptor. To make this correct, we are going to make changes in the index file. For this, come to your GMX folder and find for index.ndx, open it with Notepad++, and at the last you can see this is the sequence. This sequence is for the acceptor, 1616 for acceptor, then this is for the donor, and this is for the hydrogen. We are going to change their sequence. The correct sequence is 2624, 2636 and 166, which means donor, hydrogen and acceptor. Add this sequence and remove these two lines. Ctrl S, save these lines and close it. After making changes, run the command again, the last command again, and again here choose the last option. The last option is 23 and press enter. Now you can see the angle has been changed. The angle is now 140, which is close to 180. So this is a logical way to present it. Now the next step is to calculate the RMSD value of our ligand. For this, run this command to make a new group of atom with heavy atom. Paste it and run it. It will give you an option. Type this command. This says we are going to choose UNK. UNK is our ligand and we are going to choose its hydrogen. Then we are going to merge it. Type name 24. Here are 23 entries. We are going to create the entry number 4, in which we are going to name it UNK_heavy and press enter. Then press Q and enter. This job is completed. Now we are going to run the RMSD of UNK. We have given it the name of unk.xpg. It will create our file. We are going to use 1 nanosecond. So I modified this command. All these commands will be available in the description section. Paste this command and then press enter. It's asking you the groups. For the least square fits option, we are going to choose the backbone, which is at position number 4. Type 4, press enter. The option will change. It says select the RMSD calculation group. Here we are going to choose the group with the heavy atom. Here is the number 24. Type 24 and press enter. It is done. It is saying that your results are saved in the RMSD unk.xpg_1. This is your file in which these results are saved. Copy this file name, go to your GMX folder and search it. Then open it with the Notepad. I prefer to use the Notepad++. These are your results. These are basically the RMSD calculation which it has done for you. You can copy paste it and use it, transport into your Excel and can make graphs. Now we have completing the second part, which is analyzing protein-ligand interaction and ligand dynamics. All these commands and other things are completed. Now the last part of this tutorial is protein-ligand interaction energy. Now we are going to cover it. In this step, click on this one and download a script, Python script, copy its content. Make a new file with name ie.mdp and remove it .txt extension. Then open it and paste all the content in this file. Please note you need to make two changes. One is the energy grips here protein space UNK, and similarly at the TCP grips at here, that is the second position at line 33, you also need to change the name. Initially it was JZ4, you need to change it with UNK and then save the file. It should be protein underscore UNK and it should also be the protein space UNK. Save the file and close it. First of all, if you copy this command from here and paste into your Ubuntu and run it, it will end up this fatal error. This is a common. How to resolve it? Copy this command. We are going to make the entry because the entry is missing, so that's why it's giving error. We are going to make entry in the index command. So copy this command and enter it. This is giving you the options. From here select 1, which is our protein, and 13, which is our UNK, our ligand. So type 1 and 3 and press enter. Then type namespace 20. Here are the 19 entries and we are going to make the entry number 20 with the name protein underscore UNK. Please note that this name protein underscore UNK must be same as per your IED file. This is our ie.mdp file. This name must be same. If you change this name, then also change the name over here. Press enter and press Q. The entry is completed. Now run the command again we run previously from the Gromacs. You can copy from here or you can directly copy from it here. This is the same command. I make this file and this all command will be available for you to running in the Gromacs. Press enter and enter. Now you can see that issue has been resolved and our job is completed. Now two more commands are remaining. We have modified this command according to our ligand position, but please note that this command cannot be run in the GPU. If you run on the GPU, it will give more time. So we are going to use it for the CPU. That's why at the end we added CPU space -v, which means it will only access the CPU. Copy this command and paste it and press enter. The job is started. It will take few seconds to complete. The job is completed. Now we are left with the final command. You can run it directly from here, or we have added this command like here. This is the energy calculation. Based on these calculations, copy it and paste it. When you paste it, it will show you the parameters. These are providing the energy above these parameters. We are mainly interested in number 17, which is coal SR, it's basically number 21, coal SR, protein and UNK. So type here the number 21 and press enter. Second, we are interested in 22, which is LJSR protein UNK. Type 22 and press enter, and any other parameter you want to study. Type all those. When you are done, type 0 and press enter. When you type 0, it will give you the energy like this one. This is the energy -14. It is providing -14.96 and protein UNK is -10.1. Estimated error, their RMSD value and their dot profiles. Now all this information is available in your GMX folder, the .xvg file. You can open directly into the notepad and copy paste these files, or you can simply go open the Excel sheet, go to File, Open, and then Browse, navigate to your directory which is GMX, and open the XGB, any XGB file. Like say I will type here XPG file. Here is the interaction energy or the assembly value. I open the interaction energy, open. Then you will see this option. Select on delimited, space next, remove the tab and press the space, press next and finish. You will get all the information in the form of column. So this is the energy of each ligand, and you can also see all of your information in the interaction energy. If you find XVG, these are basically all XGV files from which you can work for further graph analysis, or you can make diagrams or so on. This is all about today. If you have any question, please ask in the comment sections. In the next video, we will cover about how you can perform RMSD calculation for ligand and protein, RMS calculation, and so on. Thank you so much for watching. Allah Hafiz.